Okay, now we're off. Shifted conic sections and how to tell the difference between them all. Okay, here you go. Parabola. You got either y equals a times x minus h quantity squared plus k, or x a times y minus k quantity squared plus h. So those are the equations, right? What's the vertex? HK. If it's an ellipse and it's shifted, we have the formula x minus h quantity squared over a squared plus y minus k quantity squared over b squared. Is that one stretched horizontally or vertically? Horizontal y. Both of them are positive. We could write the y first. A is on the bottom and A is biggest in that situation. Center is HK. Shifted hyperbola x minus h. Well, I'll write it the other way so we can talk about the difference. We'll go y minus k quantity squared over a squared minus x minus h quantity squared over b squared equals 1. Is that up, down, right, left? Come on in, Miss Wayne. Oh, no. Just 1 second, then we'll show you that. Oh, boy. What's the center? HK. Up, down, right, or left? Vertical or horizontal? Why? Why is it vertical? Y is positive. Very good. Now, I'll just tell you how to check, and then we'll do the problem. I will show Mrs. Wayne my timing system. Our timing system. How to tell. How do you tell the difference between these people? What if I give you this right here? This is one of those three. Which one is it? Is it a parabola, hyperbola, or an ellipse, or possibly a circle? Parabolas have either a y and an x squared, or they have an x and a y squared. Ellipses have an x squared and a y squared, or a negative x squared and a negative y squared. Whereas a hyperbola has a negative x squared and a y squared, or a x squared and a negative y squared. So, which one is the first one? Which one is the 9x squared minus 72x minus 16y squared minus 32y equals 16? Looks like the 9x squared is positive. The 16y squared is negative. One is positive, one is negative, so it is a hyperbola. Yeah, and science. So that's what we will do. Then we'll put it in the form, and we'll graphic find all the characteristics. Let me pause this and quick show my friend. And you are more than welcome to stay for as much as the lesson that you want. Yes. I bet you could beat all of them. We must complete the square for each part of the problem. Thanks for coming in. I want to complete the square for the x's. I want to complete the square for the y's. What should we factor out of the x's? A 9. And I'm left with x squared minus 8x. And we have to complete the square. What should I take out of the y's? Negative 16. I'll be left with y squared plus 2y all equals 16. What should we add for the x's? What? 4 is a good guess. Not quite. 16. 8 divided by 2 is 4. Squared is 16. What is the true value of that 16? 144. So if we added it to this side, we add it to the other side. you would subtract it from the same side or add it to the other side. We've done both methods. We're going to add it to this side, 144. Okay, how about the y's? What number do I add in there? 1. What's the true value of that 1? Negative 16. So I subtract 16 from the other side. I end up with, so I have 9 times x minus 4 quantity squared minus 16 times y plus 1 quantity squared equals 144. Hyperbolas have to be equal to 1. So I divide everything by 144. Divide by 144. 9 times x minus 4 quantity squared over 144. 9 over 144 reduces to 1 over 16. So we have x minus 2 quantity squared over 16 minus y plus 1 quantity squared over 9 equals 1. Oh, 2. I put a 2 in there. I'm sorry. X minus 4. Now it's in a form that we could deal with. So let's know about graphing that. Is that hyperbola going to go horizontal or vertical? Horizontal. Why? X is positive. Whatever is positive in a hyperbola, that's the direction that it goes. So what I should do is I should identify the center. What's the center? 4, negative 1. Let's find A, B, and C. What's A? 4. B? 3. C? 5. A squared plus B squared is C squared. That will give us 5. Very good. Okay. I should write that down in case somebody's watching the video. Yeah, 3, 4, 5 right triangle there. Works out. Okay. So now I can start drawing my graph. Let's draw the graph. The question is, would you have passed the marshmallow test at age 4? If I got 2 of them, yeah. All right, let's start plotting these things. I'm going to plot the center, which is 4, negative 1. Now, I like to make my box next. How many units do I go vertically? 3. How many do I go horizontally? 4. So I'll go up 3. 1, 2, 3. I'll go down 3. 1, 2, 3. Go to the right 4. To the left 4. And I'm going to use that to make my box. Once I make my box, I can draw my asymptotes. The vertices, will they go on top and bottom of the box or on the sides of the box? Sides. So I go to the sides of the box and I put my vertices Can somebody tell me the coordinates of my vertices? 8, -1, and 0, 1. Thank you. Or 0, -1. Yep. Do I now have enough information to draw it? Yep. I will tell you all the things I need you to find on the test, but the other thing we need to know is the length of the transverse axis. What's the distance between the two vertices? 8. I need the foci. Foci are located how many units from the center? 5. That's 1 extra unit outside the vertice. What are the locations of the foci? -1, -1, and 9, -1. Yep. Last thing I need to do is write equations for my asymptotes. How many asymptotes do we have? 2. In order to write an equation for a line, I need slope and I need a point on the line. Okay, what point do both of these pass through? 4, -1, the center. They both pass through the center. Slope. Our box, we went up and over. How many did we go up? 3. How many did we go over? 4. So one's going to be 3 over 4. The other one's going to be -3 over 4. Write an equation for a line. Y equals mx plus b. What is our y value? -1. M, 3/4. X, 4. B, we don't know. That's what we're solving for. -1 equals 3 plus b. -4 is b. Question? Equation for the line. Y equals 3/4 x minus 4. Any questions how I wrote an equation for a line? Those of you who are juniors taking calculus next year, you will do that many times. Right, Kelly? We did it today. Like, oh wow, calculus sounds easy. It is. Y equals mx plus b. All right, y is -1. M is -3/4 times 4 plus b. What's -3/4 times 4? It's -3. 2 is b, so y is -3/4 x plus 2. What you think about that? Any questions on hyperbolas? The next two are so much easier. This one took forever. Only 3 problems you have to do for your homework. That's it. And tomorrow you have a full work day. Because I'm a nice guy. And I bought a timing system. And I'm happy. Okay. What is it? Parabola, Mallory Gill. Why is it a parabola? Just an x squared, no y squared. This is a parabola. Complete the square right away. X squared minus 4x. What should we add? Four. Good. 4 divided by 2 is 2 squared is 4. Add 4 to that side, add 4 to that side. Now, they're not all necessarily going to be right in that form. I mean, you decide where and how you want to complete the square. You know, you could, you know, oh yeah, you just got to decide. Okay. The left side is going to become x minus 2 quantity squared equals 8y. Don't take it out. Minus 24, right? We got to solve for what variable? Y. So we should do what with the 24? Add it over. So you got x minus 2 quantity squared plus 24 equals 8y. Now, we got y equals 1/8 of x minus 2 quantity squared plus trace. That's the form that we can work with. What's the direction? Up, down, right, or left? It's y equals, so it's vertical. And it's positive, so it's up. Up. What's the vertex? 2, 3. Better find P. Anybody know what P is? Dos. Yeah. A equals 1 over 4P. A is 1/8. Equals 1 over 4P. It's always 4P. P represents the distance that the focus and the directrix is from the vertex. Oh, Tyler wasn't here. You must have gone to YouTube and watched my videos though, right? Oh. All right, P is 2. Anybody have questions how I figure out P was 2? Okay, so now we can start sketching this graph. We know that the vertex is 2, 3. Okay, plot the vertex, 2, 3. Axisymmetry runs right through it. What do we call the axisymmetry? Or what's the equation for it? X equals 2. Focus goes on the inside. Will that be up, down, right, or left? Up. How many units? 2. That's what P is. So that's your focus. What's that coordinate? 2, 5. How many units do I travel to get the directrix? 2 in the other direction. And the line goes through that perpendicular to the axis of symmetry. What's the equation of that line? Y equals 1. Length of the lattice rectum, 4 times P. What's 4 times P? 8. So how many units in each direction from the focus do I go? 4. 1, 2, 3, 4. So this line, this segment, represents the lattice rectum, and the graph travels through the endpoints of the lattice rectum. And that's my shape. And those are all the important parts. Question, Bailey Barber. Where? Well, it has a length of 8, so 4 to one side, 4 to the other. That'll give me 8. Split in half. 2p on each side. Link crew meeting tomorrow. 729. Okay, last problem. What's that equation represent? Oh, that's what they said first hour. I said the one we haven't done yet. How can you confirm, Bailey, that it's an ellipse? X squared and y squared are both positive. So it's most likely an ellipse. It could be a circle. For example, if there was a 2y squared in front, then they would have the same rate of stretching, so they would be the same. So it would be a circle. But it doesn't have a 2. So let's start by completing the square. 2 times x squared minus 6x plus y squared plus 6y equals negative 26. Complete the square. Add what? What should I add? All right. Okay, 2 times 9. So I should add 18 over here. How about y squared plus 6y? 9 again. What's the true value of that 9? 9. What's negative 26 plus 18 plus 9? 1. 2 times x minus 3 squared plus y plus 3 20 squared equals 1. Ooh, boy. Looks weird, doesn't it? This is being divided by what? 1. And instead of multiplying by 2, I can write it as divided by a half. Oh! So what that means is that a squared is equal to 1, and b squared is equal to 1/2. I did a little trick there to put it in a form that we could understand. Did you see that? Did you like that? You guys are no fun. Okay. We better get started here then. You tell me, is this going to be stretched more vertically or horizontally? Vertically, because the bigger number is under y. So that's what we need to do. First of all, what's the center? 3, negative 3. A, B, and C. What is A? 1. What's B? Square root of a half? Nope. Square root of a half. What's square root of 1? 1 over the square root of 2. Gotta rationalize that denominator as Danny did. You get square root of 2 over 2, which is approximately 0.7. Ooh. How do you figure out C for an ellipse? A squared minus B squared. So you got C squared equals A squared, 1, minus B squared, 1/2. And what do you get? A half. And you take the square root of that and you'll get square root of 2 over 2, or 0.7. Approximately. Do we have enough information to start graphing this? We do. Okay, so the center is at 3, negative 3. Right there. How many units do I go up and down? Just 1. How many units do I go to the left and right? 0.7. Draw your shape. All right. We got the center is 3, -3. We need the vertices. We need the major axis. We need the minor axis. We also need the foci. And we need the eccentricity value. The vertices are, the ends where it's stretched the most. So what are the coordinates of the vertices? Three, -2, and 3, -4. What's the length of the major axis? 2. Length of the minor axis? 2 times the square root of 2 over 2, which is the square root of 2, which is approximately, like you guys said, 1.4. The foci are located 0.7 units, or the square root of 2 over 2, from the center. So I need to add 0.7 onto that y value. And you'll get 3, -2.3. If you subtract 7 off of that center value, you'll get 3, -3.7. The eccentricity value. How do I calculate it? C over A. Oh. The C value is the square root of 2 over 2. What is the A value? 1. Square root of 2 over 2. That's it. Now, I'll pop up your assignment, and then there are a couple questions out here. I know that, in case you want to talk about this anymore. Now, I will tell you guys that conic sections, that's what we're doing right now. You have to do page 760, 21 through 23. So just 3 problems. Those are required. 24 through 26 are optional if you want more practice. And I just want you guys to know that there's a lot more that we could do with conic sections. The chapter runs much deeper than what we just talked about. In fact, it talks about degenerate conic sections. But we won't go there. Okay? Anybody have a question about one part in the notes? Anything? All right, I'm stopping the video.